All right, folks, we have spent our last 3 days working on the laws of exponents, and now we are ready to move on. So today we will start talking about adding and subtracting polynomials. All right, so to begin with, we're going to need some vocabulary here. You are going to, in today's lesson, be dealing a lot with terms. Now here's what you need to know. The terms are parts of a math problem, connected by addition or subtraction. So the parts of a math problem that are connected by addition or subtraction. So if I had the problem 2x plus 3y, and I wanted to know how many terms that had, I would start by looking for the addition and subtraction signs. And when I look at this example, I see one addition sign in it. That one addition sign is connecting two things. It's connecting 2x and 3y. So this is a problem that has two terms. All right, if I had x squared minus 9xy plus 3y squared minus 4. So if that was my problem, then I would, if I wanted to identify how many terms are there, I would start by looking for my adding and subtracting signs, which I have highlighted in yellow. And you will notice that those connect 1, 2, 3, 4 parts. So this has 4 terms. So terms in a math problem are the parts that are connected by addition or subtraction. Now, that brings us to this word polynomial. You all are aware of the fact that the prefix poly means many. Polynomial means many terms. Now notice that that's not specific. It doesn't say how many. So just to kind of give you some examples here. Let's suppose that I had 2x. 2x. When I look at that, I notice there are no plus and no minus signs. So what that means is there's only one term there. So this would be a polynomial that only has one term. And in that case, I could be a little more specific and call this a monomial. The prefix mono means one. So 2x is a polynomial that has many terms, in this case only one, and I would call that a monomial. If I had 3x plus 2, notice I have a plus sign that's connecting two things. So this would be 2 terms. And I could more specifically call this a binomial. If I had x squared minus 5x plus 7. When I look at my minus and plus sign there, I notice they connect 3 things. So this is 3 terms, which I could call a trinomial. So let me emphasize something here. All 3 of these are polynomials, but these names that I'm giving you over here are just more specific. Polynomial is very general. So if I had 5x cubed minus 7x squared plus 8x minus 1, When I look at my minus and plus signs, I notice they connect 1, 2, 3, 4 things. So this is 4 terms. And it's at this point that we stop giving them these more specific names like monomial, binomial, trinomial. So this is just a polynomial with 4 terms. A polynomial with 4 terms. So terms are connected by adding and subtracting. Polynomials have many terms, and it could be anywhere from 1 up to as many as you want. Now, in the course of this chapter, we are going to learn to add, subtract, multiply, and divide these polynomials. So you are going to learn all 4 of those basic operations. We're going to start out today with the 2 easiest. And let's begin here with adding polynomials. Now, what you need to know is adding polynomials is a 2-step process. And this first step that I'm about to write up is not going to make a tremendous amount of sense to you until you see an example. So give me a second and we'll get that example up here. When you're going to add polynomials, the first step is going to be to unwrap the polynomials. And when we say unwrap, you are going to use the distributive property, which you all are very familiar with, to do that unwrapping. So I'll show you that in a second. And then step 2 is going to be to combine like terms. So we're going to unwrap the polynomials by using the distributive property, and then we are going to combine like terms. So here's what we're talking about. Let's say we have 3x squared plus 4x minus 10. Now I want you to notice that that is wrapped in parentheses. So that is meant to show you that that is one polynomial. This specifically would be a trinomial because it has 1, 2, 3 terms. Now plus, and then a new set of parentheses. In here, let's do 6x minus 5x squared minus 9. So notice again, this set of parentheses is meant to say that this is a polynomial, and this polynomial also has 1, 2, 3 terms. In the middle here, you see your plus sign, so what that lets you know is you are taking a trinomial, and you are adding to that another trinomial. So the parentheses are meant to show you that you have one polynomial plus another. Now, here comes the unwrapping. To unwrap, we are going to use the distributive property. So what I have to do is look in front of these parentheses to see what's there. You all know, since no number is shown there, that there is an invisible 1. So on this first polynomial, we are going to distribute a 1 to everything inside in order to unwrap that. Now you all know, multiplying by 1 is not all that exciting because nothing changes. So 1 times 3x squared is still going to be 3x squared. 1 times 4x is still going to be 4x. And 1 times negative 10 is still going to be negative 10. So that polynomial is going to come out looking exactly the same as it did, but the parentheses will now be gone. When I come over here to my second polynomial, same thing. When I look here in front of the parentheses, I don't see a number, so I know there's an invisible 1 there. And he is a positive 1 because there's a plus in front of him, so I'm going to distribute that to all 3 terms in this polynomial. Now again, multiplying by 1 is not going to change anything, so 1 times 6x is still going to be 6x. 1 times negative 5x squared, still negative 5x squared. And then finally 1 times negative 9, still negative 9. So each set of parentheses here has a positive 1 in front of it. And we distribute that positive 1 to unwrap these polynomials. Now the second step is to combine like terms. The like terms are the ones that have the same variable raised to the same power. So we're going to combine those. So I'm going to start out here at the beginning of my problem with 3x squared. So that has the variable x raised to the second power. When I look at all of the other terms up here, I see that again here with negative 5x squared. So the two terms that I have just highlighted in yellow are like terms because they both have the variable x being raised to the second power. So I am going to combine those, and I'm going to do what this says. So this says to do 3x squared minus 5x squared, which would be a negative 2x squared. When we combine like terms, we should do nothing to the exponents. So notice that does not become x to the fourth power. We do nothing to the exponents when we combine like terms. All right, next up in my problem, I see a positive 4x. So that has just the variable x. I see that again in this term, plus 6x. So I'm going to combine those two terms that I just highlighted with blue. So I'm going to do a positive 4x plus 6x. So that's going to be a positive 10x. Again, notice, I am not changing that variable. I'm leaving that part alone. And then I'm going to finish this off. Here's a negative 10. Notice that doesn't have a variable. Negative 9 is just like him. He doesn't have a variable either. So I'm going to combine those two. So I'm going to do a negative 10 minus 9, which is a negative 19. And this is my final answer. That has been simplified as much as it can be. So when I add these two polynomials together, this trinomial will be my final answer. So negative 2x squared plus 10x minus 19. So unwrap by distributing and then combine the like terms, the ones that have the same variable raised to the same power. All right, let's do one more addition problem. Let's do 8x squared minus 2xy plus 11y squared. Now notice that's polynomial number 1 plus negative 5y squared minus 9x squared minus 5xy. So here is my addition problem. All right, I'm going to unwrap first. So in front of this set of parentheses, I have a 1 that I will distribute to all three terms. So 1 times 8x squared, 1 times negative 2xy, 1 times 11y squared. So notice not one thing about that trinomial changes. All right, second set of parentheses again, right here in front of the parentheses, I have a 1. And notice, because of that plus sign that is directly in front of him, he is a positive 1. So I do 1 times negative 5y squared, which is negative 5y squared. 1 times negative 9x squared. And 1 times negative 5xy. So again, not one thing changes. We are only distributing positive ones. All right, now that these are unwrapped, we are going to combine our like terms. So starting out at the beginning, we have 8x squared. So I'm looking for an x raised to the second power, which I have here. So let's combine those. 8 minus 9 makes negative 1 x squared. And you'll notice that I am choosing here not to write that 1 because he is not necessary. So we get a negative 1x squared, negative x squared. All right, my next term is a negative 2xy. So now I need a term that has an x and a y. I see that out here on the end with negative 5xy. So we'll combine here. Negative 2 minus 5 is a negative 7xy. And I want you to notice again, I want to emphasize this, that as I'm combining these like terms, I don't change the variable part. Because right now, think about the operation that we're doing. We're adding and we're subtracting right now. And we don't have an exponent rule for that. All right, so finally we have a positive 11y squared. Ends with y squared, and so does the term that's right next door. So we're going to do 11 minus 5, which is a positive 6y squared. And then there is my final answer. So unwrap by distributing positive ones on both sets of parentheses and then combine the like terms. Now I know some of you are probably looking at this and watching and saying, well, why do I have to do that unwrapping if nothing's going to change? And that will become more apparent to you when we start doing these subtraction examples next. So now let's talk about subtracting polynomials. Now what you're going to see here is that it is the same two steps. You are going to unwrap the polynomials. And that again will be done with the distributive property. And then you are going to combine the like terms. So the exact same two steps that we had with addition. So let's do 4x squared minus 9x minus 7 minus 2x squared minus 12x plus 4. So you'll see here your two polynomials are wrapped up in their sets of parentheses, and this time in the middle we see this subtraction sign that lets us know that we need to subtract these two. All right, so to unwrap this first polynomial, there's a 1 there. So we're going to multiply everything in this first polynomial by 1. 1 times 4x squared, 1 times negative 9x, 1 times negative 7. And notice again how nothing changes. Everything is the same. The only thing that happened is the parentheses are gone. Now, in front of this set of parentheses, again, there's a 1, but this time I want to point out there's a minus there. So what happens is that makes that a negative 1 that you're distributing. So this time things will change. When I do a negative 1 times 2x squared, that changes it to a negative 2x squared. When I do a negative 1 times a negative 12x, that makes it a positive 12x. And when I do a negative 1 times a positive 4, that makes it a negative 4. So on subtraction problems, when you distribute this negative 1 on the second set of parentheses, notice that what will happen is that every single sign in that second set of parentheses will change. We went from positive 2x squared to negative 2x squared, from negative 12x to positive 12x, and from positive 4 to negative 4. So on the subtracting problems, it's a little more crucial that you do that unwrapping. All right, the like terms part is the same. 4x squared, we're ending with an x raised to the second power. This is the term that has that same ending. So notice we are doing 4 minus 2 to get us 2x squared. All right, next term in line is a negative 9x. He ends with an x. So does this guy. So look what they're telling us to do. They're telling us to do a negative 9 plus 12. That is a positive 3. And that ending will be the same, so still an x. And then we have a negative 7, which doesn't have a variable, which makes him like this negative 4 on the end. So we are doing, notice, a negative 7 minus 4, which is a negative 11. So 2x squared plus 3x minus 11. And let's do one more subtraction example. Let's do 2x squared minus 3xy minus 8y squared minus negative 14 plus 3x squared minus 2y squared. So, unwrap first. This first set of parentheses has a 1 in front, and he is positive. So 1 times 2x squared, 1 times negative 3xy, 1 times negative 8y squared. All the same. But the second part of this we do need to watch because there's a 1 there in front of the parentheses, but notice because of the minus sign, he is a negative 1. So we do negative 1 times negative 14, which is positive 14. Negative 1 times positive 3x squared makes him negative 3x squared. And negative 1 times negative 2y squared, positive 2y squared. So notice on the subtraction problems that every single sign in that second polynomial will change. Like terms need to be put together. So 2x squared and negative 3x squared are like terms. 2 minus 3 is a negative 1, so we now have negative 1x squared. All right, we have negative 3xy, which is like nobody. So we're going to have minus 3xy in our answer. Then we have a negative 8y squared, which is like a positive 2y squared. Negative 8 plus 2 makes this negative 6y squared. And then notice that we have this one leftover little term here. Whoops. This positive 14. Nobody else is like him, so we'll just put plus 14 in our answer. So terms are connected by addition and subtraction. Polynomials have many terms, which means from 1 to any number you can think of. To add and subtract polynomials, you unwrap them first, and that requires that we distribute either a 1 or a negative 1. 1s don't change anything. Negative 1s change signs. And then we combine the like terms, the ones that have the same variable being raised to the same power. And when we combine those like terms, we don't change the variable part. If you have any questions about this lesson, any issues, then please be sure and let me know.